This video will teach you how to make your own custom enemy. To understand this video, first you'll need to learn how to make an entity in general, so please watch my entities and effects tutorial, linked in the description and seen by pressing the button in the top right corner of the screen. Alright, enemies in Isaac are extremely open-ended. Once you've actually defined it in the XML, you have complete control over how it behaves. Typically though, enemies in Binding of Isaac are finite state machines. This means that an enemy is allowed to be in one of any predetermined amount of states. The behavior that the enemy exhibits depends on their current state. To better explain, let me indulge you in a simple example. Let's say we want to create a slot machine. To do this, we're going to assign it two states that we will make it switch between. The two states are idle or spinning. By default, we have it in its idle state, since it's not being spun and it's not meant to give out any rewards. We have coded it so that when it is in this state, it will follow the behavior of detecting if a player is trying to spin it, which will make it easier to enter its spinning state. Now let's spin the lever. We have specified we only can spin the lever when in the idle state, and we have now put our slot machine in its spinning state. In this state, we have told it to play its spinning animation, and to pay out and enter the idle state again once it's done. As you can see, there's two distinct behaviors the slot machine can follow, and it switches between behaviors, or states, based on what we tell it to do. We split up our enemy's behavior into any number of states, and switch between the states in reaction to things happening. Today, I'm going to be making an enemy based on roundworms. It has three states. The first state will have the enemy go underground, and then reappear at a random position in the room. The second state will have it shoot a homing tear at the nearest target. And finally, the third state will have it create a rock shockwave on top of itself, causing it to hurt enemies and players around it, and to die because this is a stupid enemy idea and it should be rid of this world. This enemy will be named Level 2 Roundy, because if Nicholas can't be bothered to make original names, why should we? On screen, I'm showing the anim2 I'll be using for this enemy. I've put it in resources/gfx/monsters/roundy2 to stay organized. Remember that you can find the mod, along with its assets, in the GitHub link in the description if you want to follow along more closely. There are a few things to note here. Firstly, the dirt surrounding Level 2 Roundy is a transparent gray, and on a layer called dirt. The layer being named dirt tells the game to color those gray pixels depending on the color of the ground. Additionally, there's a green layer here named overlay effect. This is a null layer, and keyframes in this layer don't affect any actual sprites. Instead, this null layer is used to store positioning information relative to the anim2. In this case, it's called overlay effect, and it tells the game where to position status effect icons on enemies. Besides this anim2, there's also another sprite sheet named roundy2_champion.png. This spreadsheet is very similar to the original roundy2.png, and is used by the game to determine coloring for champions. The pixels of the sprite sheet we want to be affected by the coloring are half transparent, or 128 out of 255. It's very specific, so again, the transparency of the pixels that should be affected by the champion coloring is 128, or half transparency. It's important to note that this sprite sheet should be the exact same name as the normal sprite sheet and in the same location, but with _champion at the end. Now that I'm done explaining the anim2, let's go define our entity. Go to your content folder and create entities2.xml. In the previous video, I already explained how creating an entity works, so check that out if you get confused. You can find that video by pressing the little I at the top right corner of the video. Alright, I'm inside the entities2.xml file that I just created, and the first thing I'll do is create the root tag of the file. So open bracket entities, then the anim2 root, which is going to be gfx/. Remember, this is the root directory the game looks from when looking for your anim2 files. And then we're going to set the version to 5. Additionally, I'm going to add a new attribute called deathAnim2. This refers to the anim2 that will have an animation that has one frame for every enemy death portrait in the mod. Enemy death portraits are found in the bestiary and on the death screen, also known as Isaac's Will. This anim2 will be located in the GFX folder within your content folder and not resources. Again, content/GFX. I have an anim2 called enemy_death_portraits. You can name it whatever you want, but make it descriptive. Opening up the anim2, you'll see a single animation here with a frame with the portrait. I made the background of the sprite bright red so that we can find it easier in the bestiary later, but you shouldn't do this if you're to release the mod, obviously. If you have multiple enemies in your mod, you'd make another frame for each enemy. You'll learn how to connect your portrait to your enemy in a bit. Going back to our entities2.xml, I'm going to type gfx/enemy_death_portraits.anim2. Then I'm going to close that tag. So now that we've defined our root tag, let's define our entity. So open entity tag. I'm going to put the name attribute as level 2 roundy. Since there's a lot of attributes that the enemy will have, I'm going to split it up onto multiple lines so that it's easy to read and edit later. This is not required, but it is convenient to do. Additionally, do note that these attributes can go in any order you want. So on the next line, I'll put the ID. For the ID of the enemy, we have to put an arbitrary number that isn't taken by any other enemy in the game. Any ID equal to or above 1000 will not have any collision at all, no matter what, so we can't just put in a high number, unfortunately. Instead, we must put in an ID that is between some of the gaps of the IDs in the base game, and just hope no other mod takes this ID. You can check the link to the community documentation in the description, which has a list of every enemy and their ID. You can use that to find the gaps and choose an ID yourself. If your mod is adding a lot of different enemies, it's wise to make one main enemy to basically reserve an ID slot, then make all other enemies variants and subtypes of that main enemy. This will greatly reduce the chance of mod conflicts since there's only one ID that can be conflicted. I'm just going to make the ID of this enemy 678. After that, I'll put an anim2 path attribute. This is the path to the enemy's anim2 relative to the anim2 root defined up here. So for me, this is monsters/roundy2/roundy2.anim2. The next tag I'll define here is the portrait. As mentioned earlier, this is how you connect your enemy's portrait sprite to the enemy itself. Here you'll put a number telling the game which frame the portrait is on in the anim2. The anim2 being the one you defined up here. The portrait was on the very first frame of said anim2, and since frames are counted starting from 0 instead of 1, I'll just put a 0 here. Now let's create a new line. Alright, next I'm going to define the collision mass of the enemy. This will be different depending on the enemy you're making, but for me, enemies of a mass of 100 usually aren't meant to be moved, so I'll just put 100 here. Next is collision radius. So basically, all collision in this game is done using circles and capsules. Capsules just being elongated circles. You've likely heard the term hitbox before. It's a lot like that, but we're not using a box to determine if something is touching the enemy, because enemies in this game aren't perfect squares and are usually more accurately represented with a circle or capsule. I'm just going to set this to 20, as the enemy is a fat little guy and should be recognized as such. After that, we have friction. This is a number usually between 0 and 1 that determines how slippery the enemy is. Lower decimal values will have the enemy slide around more, as if walking on ice. Do note that a value of 0 will make the enemy completely unable to move. I'll set this to 1. Now let's add the num grid collision points attribute. This one is a little bit complicated, but it's basically a positive integer that determines the amount of points that are used to make up the edge of the entity's grid collision circle. So that means that the higher the number, the more accurate the collision will be with grid entities such as rocks or pots. Since this enemy isn't that big, I'm just going to set this to 8. Alright, the next attribute we'll be setting is the size of the enemy's shadow, which is done with the shadow size attribute. I'm going to be setting this to 0, actually, which will hide the shadow completely, because it's a worm, and worms like Roundy don't usually have shadows. You can set this to any positive integer, though. Next, we'll define the champion attribute. This can either be 0 or 1. 1 means that the enemy is allowed to become a champion, while 0 means it is not. I'm going to set this to 1. New line, and let's determine the enemy's base HP. The base HP determines how much maximum HP the enemy can have. Normal roundies have a base HP of 10, but this enemy is a little bit more difficult and less destructive, so I'll give it 22. Now let's define stage HP. This is additional HP the enemy will get that scales with what floor the player is on. So that means in later floors, the enemy will have more HP if I set this to a higher number. I don't want this enemy to have any stage HP, meaning it'll have the same amount of HP no matter what floor you're on, so I'm going to set it to 0. Our final attribute is collision damage. This is how many half hearts of collision damage the enemy deals to players. Most enemies have this set to 1, which means it'll deal 1 half heart of damage when colliding with the player. The game automatically handles the player taking double damage on later floors, so no need to account for that when setting this. I'm going to set this to 1. You can close the tag with an angled bracket, but we're not done yet. Within the entity tag, you can actually add some other tags that define other traits of the entity, just like how you're adding entity tags within the root entities tag. If that sounds complicated, let me show you what I mean. Create 2 new lines, and then close the entities tag, and then we'll put even more tags within this. There's 3 different optional tags you can add here, so I'm just going to go over these right now. First is the Gibbs tag. This is the main one you should care about when handling enemies. Gibbs are the guts and gore that enemies can explode into on death. It's super customizable, and you can find a list of every attribute that you can add in the documentation I linked in the description. I'm just going to use the exact same Gibbs that a normal roundie uses. So the first thing I'm going to do is set an amount attribute and then set it to 6. As you might expect, this is how many individual Gib particles will appear when the enemy is killed. Next, we can add an attribute for each type of Gib that we want, and either 0 or 1 depending on if we want it or not. A normal roundie only uses the blood, eye, and gut attributes, so I'll just turn those all on right now. So 1 for on each attribute. Remember to close that tag with a slash to signify that there won't be any tags within it. New line, and the next optional tag is the bestiary tag. If you want your enemy to appear in the bestiary, which is under the stats menu, you'll need to add this. There are 4 possible attributes that the bestiary tag can have. First, let's start with the anim tag. This is the animation in your enemy's anim2 file that will be played in the bestiary. I just want this to be my enemy's idle animation, so I'll just put idle. After that, I could optionally add an attribute called overlay, which would be the overlay animation that would be played along with the normal one. An overlay animation is simply just a second animation played on top of the first one. I'm not going to need this, so I'll just omit it. Next is a transform attribute, which is used to alter how the animation is displayed. This is actually going to be 3 different numbers separated by commas. The first number is going to be the offset from the center of the page on the x-axis. This is set to 0 for every vanilla enemy in the game, so I'll set it to 0 as well. The second is the offset on the y-axis. I'm going to set this to 0 as well because I don't want it to have any offset. Finally is the scale. That third value is a percentage that represents the size of the sprite. So 0.5 will be 50% the normal size of the sprite when displayed in the bestiary. I'm just going to set this to 1, meaning it'll be the normal size. There's also another optional attribute called anim2 path. This just defines an anim2 to use for the bestiary instead of the enemy's normal one we defined up here. I want to just use the default one, so I'll also be omitting this. The last attribute is another optional one called alt. Something I didn't go over in this video is that you can actually easily add alternate sprite sheets for your enemy for certain vanilla floors with the has floor alts tag. The same documentation that lists all of the Gib attributes also explains how to add alternate sprite sheets, and it does it very well, so I'm not going to do it myself. Instead, just know that you can set the alt tag to one of these suffixes on screen, and it'll use that as an alternate sprite sheet. Again, I don't need an alternate sprite sheet, so I'm just going to remove this and then close the tag with a slash. Now, the very last optional tag that we can use is the devolve tag. In a semi-recent patch for Repentance, The D10 was changed to devolve enemies and replace them with a weaker counterpart. The very cool thing about the devolve tag is that you can turn enemies into any type of entity in the game, including grid entities like rocks. Let's open up the devolve tag, and to choose an entity, create an ID attribute. This will be 3 different numbers separated by periods. The first number will be the ID of the entity that the enemy will transform into. Do note that effect entities will have an ID of 999 instead of the usual 1000 here, because 1000 is actually given to grid entities such as rocks and pots. I want this enemy to turn into a normal roundie when devolved, so I'm going to set this to 276, which is the normal roundie's ID. Then a dot, and then the variant. I also want this to be the exact same, so I'll set this to 0. Lastly is the subtype, which I'm going to be setting to 0 as well. After that is the weight attribute. I've done a lot of testing, and I don't think this attribute actually does anything. My guess is that it's a cut feature where the D10 could have devolved enemies into a random list of enemies instead of it being the same enemy every time, but I don't actually know. Every enemy in the game that can be devolved has this set to 1, so I'm going to do the same. Alright, close that tag, and we're now done with the XML. It's obviously a lot at first, but once you've made one entity, you can just copy and paste the original entity's tag and change it accordingly for your new entity. Alright, let's save, and then go in game to see the enemy we just created. Alright, first let's look in the bestiary, which is under the stats menu. Modded enemies will just appear wherever they want in the bestiary, which is why I made the enemy's portrait have an ugly red background. There it is. Awesome. Alright, now I'm gonna run, and I've given myself the D10. To start, I'm just gonna type spawn level 2 roundie, and then manually type out the ID from there, so that spawning a champion later on is gonna be easier. So 678.0 and then .0 for the subtype. There it is, in all its glory. Colliding with it will deal contact damage and slide it around, because we haven't used Lua yet to make it immovable. Let's devolve it, and it's turned into a normal roundie. Now let's spawn a rainbow champion to test the champion colors. We can do this by pressing the up arrow to use the last command, and add an extra dot at the end of the ID, corresponding to the champion variant. The variant for the rainbow champion is 25, so I'll put a dot, then 25. Okay, I accidentally added a black background to the champion's sprite by accident somehow when recording this, so I think that's pretty funny, but let's try spawning it again. There it is, it's gay now. Awesome. Alright, now that we've tested the enemy, let's get to coding. Here's the main.lua. I've already registered the mod up here. The first thing we should do is get the ID of the enemy. Technically, we could just type in 678, which is what we put in the entities2.xml, but the game has systems in place to shift IDs if they conflict. So you should just create a new variable called ID, then use isaac.get entity type by name, and type in the exact name of the entity as you defined it in the XML. So level 2 roundie. Remember, this is case sensitive, so please type it exactly as it is in the XML. Also, under that, we're going to define a variable called game and set it to a game object that we create. We're going to be using this object later, and it only needs to be created once in your entire mod, as it stays valid forever. We'll be using it to teleport the worm to a random position in the room later. A few new lines, and next we're going to define a constant. A constant is just a name for a variable that we don't intend on changing later. We'll define it in shouting snake case, like that, to easily distinguish it from normal variables. This is all to just increase readability in our code for when we're looking at it later. Name this variable bullet_speed, and set it to whatever you want. This will be the speed the projectile that the worm shoots moves in, so I'll just do 6. Alright, make a couple new lines, and let's start making our callbacks. The first callback we want to make is one that'll run when the enemy is first initialized or spawned. We're going to put the code that prevents the enemy from being pushed around in here. So make a new function, mod:_roundy init. The event that we're hooking into provides the NPC as the first argument, so we'll define that here within the parentheses. Additionally, if you saw the previous tutorial where I went over type annotations, you'd see that I can type this comment above the function and get full autocomplete for roundy as an entity NPC. I'll link that tutorial in the description. Although this comment and that tutorial are not required for this video, it'll help immensely for learning how to organize your mod. Also note that this won't work unless you have the 2 Visual Studio Code plugins that I recommended in the passives item tutorial that are on screen right now. Alright, close this function. And now let's add some entity flags to the NPC. Entity flags are something called bit flags that decide certain behaviors that the entity will have. A bit flag is a data structure that is basically just a sequence of bits, which are just numbers, that store flags, which are just Boolean true or false values that signal a special code condition. The very cool thing about bit flags is that you can store a bunch of different flags in one number, which is better than creating a variable for every possible option. Plenty of things use bit flags, but they're a bit complicated for someone new, so I'll simplify it. Let's start with running the add entity flags method on the roundy. Within these parentheses is where we'll put the flags. Type entity flag.flag_no_knockback. Entity flag being the enumerator to the no knockback flag. Now add a pipe symbol, also known as that vertical line that you didn't know the name of until 3 seconds ago. And then type entity flag.flag_no_physics_knockback. So basically what this does is that it combines those 2 flags into one number, which we can provide to this function, and will change those basically settings of the entity. If that was a little bit confusing, that's okay. Just remember that you can use this pipe symbol here to combine bit flags, which makes using methods like this one a lot easier. Alright, that's actually all we need to do in this function, so let's go down a few lines and let's connect it to an event. Do mod add callback, open parenthesis, and then we're going to use the mod callbacks.mc post npc init event. As you might expect, this event runs when the NPC is first spawned. Add a comma, then type the name of the function we'll be using, but with a dot instead of a colon. The dot tells Lua that you are referencing the function instead of calling it. Then finally add another comma, and we'll put the ID of the enemy in here as the final argument. This is one of the events in the game that allows you to specify a third argument to narrow down when your callback is run. Alright, now for the fun part, which is the AI. Let's create a new callback, and this one will run every game update for the NPC. So create a few new lines. We're going to set it up similar to how we did for the initialization callback. Type function mod roundy update with roundy between the parentheses. And also add the type annotation we added earlier right here. Close the function and go between it. Now let's start defining a few variables that'll help us later on. First, we'll define a variable that will store the NPC's sprite. We're going to be looking at the sprite a lot so that we know when animations are finished playing, which will tell us when to switch states. So local sprite equals roundy get sprite. Additionally, we are going to have a variable that holds the enemy's target. Sometimes enemies can get distracted by familiars such as the punching bag and won't be targeting the player. We're going to create a variable called target and use roundy get player target to get whatever the NPC is currently focused on. Alright, now think back to when I explained states earlier, because we're going to be putting that knowledge to action. All enemies are spawned in the init state. When it's in this state, we're going to wait until it's finished with the appear animation, which is played by default, then switch it to the move state, which will signify that the NPC is digging into the ground and appearing somewhere else. So make a few new lines and do if roundy.state equals npc state.init, then And remember that this is just an enumerator, which points to a number. You can technically put any number for the state of an NPC, but I recommend using the NPC state enumerator because it makes things easier to read later on. Now, within this if statement, we're going to check if the appear animation is finished. So do if sprite is finished, and then the name of the animation, which is appear, then. Now we're going to change the state of the enemy to the move state. So roundy.state equals npc state.move. The move state is going to check if the dig into the ground animation is finished playing before teleporting the worm into the room. So let's actually play that animation on the sprite. So make a new line and type sprite play, and then the name of the animation, which I called dig in. And this second argument here is whether or not we want to interrupt the current animation to play the new one. We can set this to false because the previous animation is already finished at this point, or we can just omit it altogether. Alright, let's do the movement behavior. Under all these if statements, we're going to check to see if the current state is the move state. So if roundy.state equals npc state.move, then. And now this next part is actually surprisingly simple. All we have to do is check if the dig in animation is done, and if it is, find a random position in the room and set the worm's position to that, then play the dig out animation before switching the state. That actually does sound a little bit complicated, but I promise it's not that bad. So like we did before, let's check if the sprite is finished with a dig in animation. With if sprite is finished dig in, then. Now we have to get the current room object and use that to get a random position within the room. This part may be a little bit tricky, so pay attention. Let's create a new variable called room. Then use that game object from earlier and use the getRoom method to get an object representing the current room that the player is in. Now let's create a new variable called newPosition. We'll use the getRandomPosition method to find a random position within the room. The only argument it requires is called margin, which is how far away the NPC must be from any obstacles such as rocks or pots. I recommend just setting this to the NPC's size, so roundy.size. The size is what we defined in the XML earlier. Okay, now we just have to move the worm to the new position and make it play the dig out animation, then change the state. The dig out animation also tells us when the worm is going to shoot, which I'll get into in a bit. So first, let's start with setting the position. All you have to do is roundy.position equals new position. Then let's play the animation. So sprite play dig out. And finally, let's set the state to npc state.attack. So roundy.state equals npc state.attack. This is going to be the final state we have to set up. Let's go down a few new lines. In the attack state, we'll handle shooting the homing tier and spawning the shockwave. Start with if roundy.state equals npc state.attack. Then create a few new lines. Alright, let's first handle shooting the actual tier. Heading back to the ANM2 that we're using, you'll see this pink layer here called triggers with a single keyframe. We can then use Lua to detect if the event is playing and react to it. To make an event, head to this little box right here and click Add. Then create a trigger keyframe by clicking the triggers layer and clicking Insert Keyframe, selecting that keyframe, and then clicking the name of your event. I'm going to close without saving. Now back in our main.lua, to detect if the event is currently being triggered, do if sprite is event triggered, then the name of the event. So for me, it is shoot. Then close that. We first have to define how the projectile will actually behave. To do this, we're going to be creating a new variable called params and store a projectile params object within it. This will create an object that we can edit to our liking that control the behavior of the projectile that we're going to shoot. Now, the only thing we'll be doing is making the projectile home in on the player, which is a bit flag, which I already explained earlier for entity flags. We only need one flag this time, so simply do params.bulletFlags equals projectileflags.smart, which just means homing. Now let's create a couple new lines, and remember that we also have to get the velocity of the bullet we'll be shooting. So here comes a little bit of math. The velocity is essentially the speed and direction in which the projectile will be moving in. We're going to create a new variable called velocity. First, we want to get a direction from the enemy to the target. We do this by getting a directional vector. Vectors, in math terms, are objects with both magnitude, aka size, and length. We want to get a vector which only stores length, which you can then multiply by the bullet speed constant we defined earlier. To get a directional vector from the enemy to the target, we're going to have to subtract the target's position by the enemy's position. This next step is very important, so listen closely. Open a parenthesis here, and then type target.position minus roundy.position. And then make sure you've closed the parentheses. If you do this in the opposite way, you'll get the opposite direction, so make sure you're doing this right. Within these parentheses, we have a perfectly good vector object. We can then normalize this vector object. Normalizing basically just makes the vector have a length between 0 and 1, so we'll purely have the direction and not the magnitude part. Add a colon at the end of the parentheses and make sure you type normalized with a D at the end. Remember, this is a vector object, so putting it within these parentheses here lets us quickly use it without having to create a whole new variable. Then simply multiply this by our speed, which is that constant we defined earlier. So bullet underscore speed. If that was confusing, that's okay. Math is pretty hard. So just know that this line of code takes a direction and then multiplies it by a speed to get a brand new vector object. All right, now that we have the velocity in which the projectile will move in, let's fire the projectile. So under that, call a method on the roundy called fireProjectiles. This is going to take a bunch of arguments. First is the position of where the projectile will spawn, which is going to be the worm's position. So do roundy.position here, and then add a comma. Next is the velocity, which we just got, so type in velocity. Now, the third argument is projectile mode. This determines how many projectiles are shot and how they are shot out. We're just going to be shooting one projectile, and since projectile mode does not have an enumerator, we're going to just have to type in 0. You can find a list of every projectile mode in the link in the description. Lastly are the parameters that we defined earlier, so params. Okay, we have fired our projectile. The last thing we want to do is have the worm commit self-eternal sleep when the dig out animation has ended. I can't say the word, I don't think. Under this if statement here, type if sprite is finished, then dig out, then. So again, the worm will die, then shoot out a ring of rock shockwaves. Rock shockwaves are simply an effect, like the ones you see when using wait what, and we can kill the worm by using the kill method on it, like this, roundy kill. To actually spawn the shockwave, we'll be using the isaac.spawn function. Create a variable called shockwave, then type isaac.spawn, again with a dot instead of a colon when you're using the Isaac class. Open a parentheses, and we're going to create a new line and put each argument of this function on a new line. We're going to do this because this is a very long function, and to keep things readable, we're going to make it span across lines. So the first argument is the entity type, which is just the ID of the entity. We're going to be spawning a shockwave, which is an effect entity. So just type entity type dot entity underscore effect. Create a comma and then create a new line. For the variant, we'll do the effect variant for a radial shockwave, which is just effect variant dot shockwave. The subtype doesn't actually matter, so just set this to 0. Now is the position. The position is going to be on the now dead level 2 roundy, so just do roundy.position. Next is a velocity vector. We don't want the shockwave to just be sliding around, so we can just set this to a vector where the x and y properties are 0. We can quickly do this by just typing vector.0, which is a constant. Now, the last argument is the spawner of the shockwaves. Set this to the roundy itself, as it's what spawned the shockwave, even though it's now dead. As you can see, splitting it across multiple lines would be a lot more readable than making it just one long line. Okay, the very last thing to do is just to set the parent property of the shockwave to the roundy so that the game knows that this is an enemy-spawned shockwave and not a player-spawned one. To do this, simply do shockwave.parent equals roundy. We are almost done. We just have to hook the callback to the MC_NPC_update event. At the very bottom of the file, type mod add callback, open parenthesis, mod callbacks.mc_npc_update. Then add mod.roundyUpdate to reference the function. Remember, it's a dot and not a colon. And then finally, add the ID of the NPCs. The callback only runs for our NPCs updates. Alright, make sure to save, and let's restart Isaac to test out the enemy. Alright, I'm going to spawn it now. I'm just going to open the console and use the up arrow to use the commands I used previously. Here it is. Yep, that's definitely what we coded. And that's all for this tutorial. It was a long one, and if you have any questions, feel free to join me on my Discord server, linked in the description of this video, or join the Modding of Isaac server. It's a lot easier to get help if you join one of those servers than if you use the comments. Anyway, that's all. Thank you so much for watching, and goodbye. God, this was an hour and a half long recording.